In this video, I'm going to look at a database normalization exercise, and we're going to go to the second normal form. So we imagine in normal form that we have some sample data and that we would like to either reconstruct the database from which it was generated, or we've given some report and we've been tasked with the idea of developing the database. And so here we go. So we have kind of like student transcript information. So we have like the name of the student and then some list of courses that the student has taken. And the first step in a normalization process is that we don't like multi-valued fields. We don't like lists. So I have this, I have this student information, and then I have this list of courses. And when I want to search for something, I don't want to have to, I don't want the responsibility of, parsing some list and finding, math 150 within a list of courses that Mary McDermott may or may not have taken. So the first thing we do when we have lists, multi-valued fields within one of the fields, is we say we flatten the table. So we take the information that is sort of for all of the list, in this case, Mary McDermott's information, and we repeat it for each row of that field. So we're taking Mary Margaret's information here, and we'll copy it. And I think that's the right kind of paste. Word has a number of different kinds of paste, but I want that third paste in there, and I'm pasting Mary McDermott. So I'm making individual rows for each course that Mary took. I'm repeating her information and making a row for Mary taking a particular course in a particular semester, getting a particular grade. And now I will do the same for my second student here, James Jameson, and just repeat that information. And this is called flattening the table, and we're sort of introducing some redundancy, and we usually don't like redundancy in databases. But what we are gaining here is that when we search, we don't have to parse. We don't have to break any lists down and find something in a list. Everything will be its own like atomic little value. If I'm looking up math 150, like there it is. Okay. So now the next thing is to find, we have these flattened rows that we've made, and now we want to identify for this table a primary key for these now flattened rows. So the purpose of a primary key is to uniquely identify each row. So we want to know what information. So it's possible that Mary and John took the same course, even in the same semester, not even gotten the same grade. So we're certainly going to want some student information. And so it's setting up their student ID. So that will be part of our primary key. And the idea when you're working in second normal form is we could sort of introduce some sort of transcript line ID for each row, but we don't want to do that, at least not yet, because the second normal form will be based on our primary key. And if we introduce a primary key, it won't, we'll be stuck. Other higher levels of normal form will allow us to proceed, but the second normal form won't get us anywhere. And since we're only going to go to the second normal form, I don't want to be stuck from the start. So I'm not going to introduce some primary key for the table. I'm going to find a composite primary key, parts of what are here that will make it unique. So the student. Now I need some course information. A student took a number of courses. Whenever you flatten, So you had this sort of list of this multi-valued field, this sort of list of things. Something from there has got to appear in your primary key. There may be situations in which that thing is the overall primary key. Like if there was something in here that would allow me to identify this student, but there's not going to be. Maybe within this sort of very small set of data with just, Mary and John, maybe I can figure out, if they never took the same course in the same semester or something like that, maybe that. But overall, once I did like a whole college or something like that, all bets are off. So I'm going to need course information. Now, I don't have a simple course ID like I did for student ID, and I can consider adding one. I'm not going to at this point, but but I might, in the longer run. But I'm going to say there are multiple English courses, so English isn't enough. There are courses with the same number that are for different departments, like religion 150 and math 150. So I need to identify a course, I need both the department and the course number. So I'm going to put them here in my list of creating a composite primary key. So a department and some kind of course number. And then I always have to imagine not just the data I see, which is only 2 students, but other data that might come. And one situation I want to consider is that a student might retake a course. Now, these student Mary and John are like reasonably good students, and we're getting A's and B's and everything. But imagine that, Terry came along and Terry failed something, so I got a D, and so Terry wants to retake the course. So I can't determine the grade for the course just by saying the student and the course. I'm going to need to know also the semester. And so that will be the last part of my composite primary key. I've also been known to call it a compound key, but I think composite's the more accepted term. So those are my composite primary key. I want to identify the student because this, I need to tell one student from another in these records. I need to tell one course from another in these records. And because the student can retake the course, I need to distinguish the semester. And I can't really say the grade determines the semester because the person may retake the course and get the same grade, fail it twice or something. It happens. Okay. So there we go. That is our primary key. It is composite. And that's often what happens in a flattened file. It's possible that, when you found, again, the thing that was repeated has to participate in the primary key, but it's sometimes possible that that determined all the rest. Maybe if I had an album and then a list of songs on the album, and if the song only appeared in one album, or if we are talking about, the the first album the song appears on or something like that, then maybe I can say, oh, the song determines the album. But here with students and courses, I need the student and the course and the semester. I need it all. Okay. So there we are. We have our form. Now our next step is we are looking for functional dependencies. Then I can, given one thing, I determine in some way, including just looking it up, the other things. So if I have a student's ID, I can then look up that student and find their first name, their last name, their middle name. So that uh, student ID, and I'm going to just draw an arrow to say determines. The student ID is determinant of, or determines the first name, last name, middle name. And If I had other people in my database, like teachers or something like that, or advisors, then I might want to say student first name, student last name, student middle name. But I'm just repeating sort of what was above. And it was just first name, last name, first name, middle name. So there they are. Now, also we have the major. Okay. So when I presented this exercise, this question of major led to an interesting discussion. Um, Somebody suggested that major belongs to department. And so so there was this department English, and then there's a major English. There's a department of computer science, and there is a major of computer science. So there is certainly some connection. Major has something to do with a department. And it's sort of like a relationship between a student and a department. A department will offer a major, and a student takes a major, and therefore the major sort of connects a student to a department. Um, and that will have to sort of come out in some longer run. But we're not going to do that here. We're going to say that there are two distinct fields, major one and major two, and they are properties of the student. That when I look up a student, I can see what the student's primary major is. I can look up what the student's secondary major is. And and we're going to imagine that like it stops there, that the student doesn't have a third major. Um, and so we're going to add major one and major two to properties determined by the student ID. But in a more fleshed out example, we might want to develop these majors into somehow a relationship to a department between a student and a department. But for now, we're just saying properties of student, and we'll leave it at that. So this is one functional dependence. The student ID determines all these things. What else do we have up here? The course information, the department and the course as a combination determine a course name. Okay. Now I'm not going to, but I could say introduce some sort of course ID, but I'm just going to leave it as what was shown above. So I'm going to say the combination, the composite key of a course number, department and course number as a combination determine the course name. And then you might have like a course short name and a course long name and a course description, and there may be more, but we're just going with what is seen and up above. And so that's all that's going to be determined above by the department course number combination. And then there's only one thing left that's not uh, so we had all these fields determined by student ID, the course name determined by department and course number. And then finally, there is the only thing left that's not already part of the primary key is grade. And I can't say that one part of the primary key depends on another. Then we don't need it as part of the primary key. So there's sort of like this minimal implication in the primary key. So like none of these things determine no part of the primary key determines another, or you would just leave it out of the primary key. So the only thing remaining is the grade, and that depends on everything. The grade depends on the student, the grade depends on the course, the grade depends on the semester. The student may retake the course. So it's sort of all four. And I didn't want to take them out. I wanted to copy and then paste down here. And then that determined the grade, the whole set of four of them. Okay, so these are my functional dependencies. Again, I can look up. If I know the student, I can look up their first name, last name, middle name, major one, major two. If I know the department and the course, I can look up the name of the course. If I know the student and the department and the course and the semester, I can look up the student's grade in that course. And that's all my fields. So these are all my functional dependencies. And now the next question I ask when looking at second normal form is, are any of these partials? So it's just, I'm looking at part three and part two and sort of saying, are any of these things that determine other things part of my primary key? And there are sort of three possibilities. It could be something that determines something else is not part of the primary key at all, or that it depends on the full primary key. So I don't have any of the first, and then it could be partial. So it could be, depends on the full primary key. It could depend on part of the primary key. It could depend on none of the primary key. I don't have any examples of none, but I have an example of something that depends on everything, the grade, and something that depends on partials. So I'm just going to grab. So up here, I'm just sort of saying of my list of dependencies, here are the two that are partials. Okay. And then I am decomposing, I am normalizing, I'm making my one great big table into smaller tables by pulling this out. So I have a student ID that is determinant of all this information that is student information. So that's telling me I'm going to have a student table that is going to have student ID, and I'll put PK for primary key. And then that determines all these other things. So all these things that are determined by just the student ID are I'm going to pull out. I have this department course giving me the course name. So I'm going to call that uh, course. And then that is dependent on department and course. Just control V, and I'm going to leave that as a composite primary key. I could introduce a new key, but I'm going to leave it as a composite key, department and course number as a combination. And that was determining the course name. And as we said, we could do a description and yada yada, but we're just going by what was in the original table. So it's just course name. And then we need something that depends on all of them. We don't want to lose grade, and we don't want to lose the dependence of the student taking the course in a certain semester and getting a grade. And so I'm going to call that, I don't know. Sometimes I just use the names like student course semester or student course grade or something like that. If I can't think of a better name, then I just sort of uh, put the names of the tables that are being sort of linked together in sort of this big obnoxious long strand. But I'm going to call it, I don't know, a transcript line now. And that is all of these things determining a grade. So these were all some kind of composite key. That's getting a bit many things for a composite key. So I definitely be tempted here to introduce like, a transcript line ID or something like that. But this will do. So that is a second normal form exercise. Just to repeat, we took any multi-valued fields and we created individual lines for each of them. This is called flattening the table, and it puts us into the first normal form. The first normal form says there are no multi-valued fields, and we do this for the purpose of searching. But it improves searching, but it gives us a lot of redundancy, and so we start moving to the second normal form to start reducing some of the redundancy. So we identify a primary key. We need to identify each row uniquely. In our example, that took 4 fields for us because a student might retake a course in different semesters. So we needed the student information, we needed the course information, we needed semester information. We looked for our functional dependencies, things that determined other things, and knowing the student and the department in the course and semester doesn't determine the grade, but it allows us to look up the grade. So we say it's determinant in terms of the database if we can look it up. So I can giving the student information, the department information, the course information, the semester information, I can look up how the student did in the course. So we call that determinant. And so we pick out our functional dependencies. And then that was step 3. In step 4, we're picking out the partials. It could depend, we might find a dependence that has nothing to do with the primary key. We can have a functional dependence that has to do with part of the primary key. We can have functional dependence that depends on all of the primary key. And the second normal form tells us to focus on the partials. So of the 3 we identified in this example, 2 of them were partials. And then you pull out tables based on those partials. You will have sort of the original sort of table with all of the primary keys in it. Um, and then you sort of examine your relationships. So I needed all 4 things to determine a grade. So this one was straightforward. But sometimes I won't have any field here that's dependent on all the other things. But I still may need that last table to keep my relationships intact, or maybe something with 4 things will break into things with 2 or 3 or something. But I need to when I break something down into when I'm doing normalization and I break something down, I want to make sure I can get back to the original using join. So I want to make sure I maintain my relationships. And so grade depended on all 4 things. So that keeping that last table intact was sort of natural here. But even if you didn't have this field that depended on all 4 other things, you have to like examine this last table and say, do I need it or something like it to keep my relationships? The relationships are crucial. Do not lose them in the normalization process. That's it for this one. Thanks for your attention.